Imagine waking up one morning to find that America has no presence in space. No astronauts in orbit, no station overhead. Just a gap, a silence where human spaceflight used to be. That scenario is closer than most people realize. In less than 5 years, the most expensive and complex structure ever built by human hands will be deliberately destroyed, plunged into the Pacific Ocean in a controlled re-entry. And the replacements? They don't fully exist yet. The International Space Station, a $150 billion engineering marvel assembled piece by piece over more than a decade, is scheduled for retirement in 2030. NASA has made the decision. The question is no longer whether the ISS will end, but whether anything will be ready to take its place before the last module burns up on its way down. 2 companies are now in a race against that clock. One is following the old rulebook almost to the letter. The other is tearing the rulebook apart and building something that's never been attempted before. Both are betting billions. And in one of the most fascinating dynamics in modern aerospace, both are almost completely dependent on the same company to succeed. To understand why this race matters, you have to understand what's really at stake. The concern isn't just optics or national pride. A gap in American human spaceflight capabilities would have real, lasting consequences. Scientific, economic, and geopolitical.
China's Tiangong station is not sitting still. It continues to grow, expand, and develop research programs that will run uninterrupted, regardless of what happens with the ISS. If the United States loses continuous access to low Earth orbit, even temporarily, it falls behind in microgravity research, in the development of in-space manufacturing, and in the kind of operational experience that only comes from actually living and working in space. The ISS is already showing its age. Recurring air leaks have become a persistent concern. Russia, which originally committed to operating the station alongside the US through 2030, has hinted it may reduce participation before that deadline. Every year that passes increases the probability of an unexpected failure that forces an early end to operations. NASA recognized this problem years ago. Rather than attempting to build another government-owned station from scratch, a process that would take too long and cost too much, the agency turned to the private sector. Through the commercial LEO Destinations program, NASA is funding private companies to develop and operate commercial space stations, with the government becoming just another paying customer. The logic is straightforward. Let industry move faster, take on financial risk, and build businesses that don't rely entirely on government contracts. The agency keeps its access to orbit.
Private companies get a massive head start in what could become a multi-billion-dollar industry. But if those companies fail to deliver on time, the US temporarily loses its continuous human presence in orbit. The strategy is smart. The risk is real. And that pressure, that quiet fear of a gap, is exactly what has turned SpaceX into something much larger than a launch provider. It has become the infrastructure beneath America's entire post-ISS future. SpaceX, the company holding everything together. SpaceX built its credibility during the commercial crew era. After the space shuttle retired in 2011, the United States spent years paying Russia for seats aboard Soyuz spacecraft to reach its own station. It was an embarrassing dependence on a foreign power for access to a structure America helped build. SpaceX ended that. Falcon 9 and Crew Dragon became the backbone of American crew transportation to the ISS, flying astronauts with a reliability and cadence that no other Western commercial system has matched. That trust, built over years of successful missions, is now the foundation on which both commercial station companies are constructing their futures. Falcon 9 launches the stations. Crew Dragon carries the astronauts. Starlink powers the communications. And soon, Starship may completely transform how orbital habitats are built and deployed. For any company trying to build a station, choosing SpaceX isn't a gamble. It's the safest possible decision.
Axiom Space, the conservative bet. Axiom Space approaches the future of space stations the way an experienced architect approaches a renovation, carefully, methodically, and with deep respect for what was already built. The company is so intertwined with SpaceX at the operational level that the two are almost inseparable. Every crewed mission Axiom has flown, from Axiom 1 through Axiom 4 and beyond, has launched on a Falcon 9 and carried astronauts aboard a Crew Dragon. SpaceX also supports astronaut training and mission preparation, giving Axiom the operational experience it needs before its own station ever sees orbit. What makes Axiom interesting is the tension between its branding and its philosophy. The company markets itself as part of the commercial space revolution, yet its architecture looks remarkably similar to what NASA engineers designed decades ago. Modular cylindrical habitats, conventional docking systems, NASA-compatible infrastructure, familiar certification standards and safety processes. There is nothing accidental about this conservatism. It is a deliberate strategy to minimize risk and maximize credibility. Rather than attempting to launch a fully independent station from day one, Axiom is taking a transitional approach. Attach its modules directly to the ISS while it's still operational, then detach when the station retires and continue operating independently. It is the aerospace equivalent of building a lifeboat while still on the ship.
The plan is rolling out in stages. The first Axiom module, a payload, power, and thermal module, is scheduled to dock to the ISS's Harmony node in 2027, providing power and thermal control functions for the growing Axiom segment. The second module, Habitat 1, is expected in 2028, adding accommodation for 4 astronauts, along with research and production space. Each step is deliberate, each milestone building credibility for what comes next. Axiom's leadership reflects this bridge between eras. The company was founded by Michael Suffredini, who spent a decade as NASA's ISS program manager, overseeing one of the most complex engineering projects in human history. That institutional memory is something no startup can replicate. Suffredini understands not only how to design a station, but how extraordinarily difficult it is to keep one functioning in orbit year after year. Beneath the conservative architecture, though, something more ambitious is taking shape. Axiom is building for customers the ISS was never designed to serve: space tourists, private researchers, commercial manufacturers, filmmakers, and independently funded astronaut missions. The company moves with a speed that traditional government programs rarely achieve. NASA rewarded that combination of heritage and agility with roughly $140 million in commercial LEO destinations funding, while private investors have added hundreds of millions more.
It is a company that has placed one foot in the past and one in the future, and that positioning may be exactly right. VAST, the moonshot. While Axiom carefully navigates the transition, VAST is doing something entirely different. It is trying to skip the transitional phase altogether. Founded by Jed McCaleb, a billionaire tech entrepreneur best known for his work with Ripple and Stellar, VAST is pursuing a radically faster approach. Its first station, Haven 1, is targeting launch in 2027. Not as an attachment to the ISS, not as a module awaiting future hardware, as a fully independent, operational station from the very first day. That timeline is, by any aerospace standard, extraordinarily aggressive. What makes it even remotely plausible is the depth of VAST's relationship with SpaceX. Haven 1 is being designed around SpaceX hardware almost from the foundation. Falcon 9 launches the station. Crew Dragon transports the crew. SpaceX trains the astronauts. And Dragon itself becomes part of the station's operational infrastructure during docked missions, including critical life support capabilities. Rather than building every subsystem independently from the start, VAST is leveraging the proven reliability of Dragon to simplify the station's early design and reduce technical risk. It is a Silicon Valley approach applied to orbital mechanics. Outsource what already works, then focus internal resources on the bigger vision.
The first crewed mission, VAST-1, is planned to send 4 astronauts aboard a Crew Dragon shortly after Haven 1 reaches orbit, creating one of the fastest station deployment to crew timelines ever attempted. VAST has also secured something that could quietly become one of Haven 1's most significant advantages: a direct integration of SpaceX's Starlink laser network for communications. Compared to the patchwork relay systems that older stations relied on, the difference is hard to overstate. Scientific data transfers become dramatically faster. Real-time video communication improves substantially. Even the psychological experience of long-duration missions changes when astronauts can feel genuinely connected to Earth rather than isolated from it. The artificial gravity experiment nobody else is trying. For decades, living in microgravity has been one of the fundamental realities of space station life. Astronauts on Mir and the ISS have spent months experiencing bone density loss, muscle atrophy, fluid redistribution, and cardiovascular changes. These are not minor inconveniences. They are serious medical problems that become critical obstacles when considering long-duration missions to the Moon or Mars. The human body was not built for weightlessness, and every month spent in orbit carries a measurable physical cost. VAST wants to attack this problem directly.
Haven 1 is intended to serve as an early testbed for rotational artificial gravity, using centripetal acceleration generated by spinning the station to simulate gravitational force. The initial goal is modest, roughly approximating lunar gravity levels, but the implications of even a partial success are enormous. If the technology works, future stations could scale up to much larger rotating habitats capable of sustaining healthier long-term human life in space, a fundamental requirement for any serious attempt at a permanent presence beyond Earth orbit. Haven 2 and the Starship Gamble. The first Haven 2 module is expected to launch on a Falcon Heavy in 2028, larger than its predecessor, stretching roughly 16 meters and including 2 docking ports to support future expansion. Between 2029 and 2030, 3 additional modules are planned at a rapid pace of approximately 1 every 6 months, forming a linear station capable of supporting 8 astronauts simultaneously. Then comes the defining moment. In 2030, a SpaceX Starship is expected to deliver a massive 7-meter-wide core module into orbit, something no rocket before Starship could physically carry. Once installed, the structure transforms into a cross-shaped complex with expanded living space, an EVA airlock, and a 5th docking port. That single launch could represent a fundamental shift in how space stations are built.
For decades, stations were assembled incrementally because no rocket was large enough to launch major habitats in a single flight. Starship changes that calculus entirely. By 2032, VAST plans to add 4 more modules, bringing the total station to 9, enough to accommodate up to 12 astronauts at a time. The deeper story. On the surface, this is a story about 2 companies racing to replace a retiring space station. But the deeper story is about something that has quietly taken shape over the past decade. SpaceX has stopped being just a transportation company. It is becoming the foundational infrastructure of American human spaceflight. The roads, the power grid, and the communications network of a new orbital economy. Whether Axiom's careful, step-by-step approach or VAST's moonshot philosophy ultimately succeeds, the answer will depend heavily on the rockets, spacecraft, and satellite networks that one company controls. The race to replace the ISS is real, but in many ways, it has already been shaped by the company watching from the sidelines and quietly holding the keys to everything.